Hey guys, it's Mr. Graph, and I'm going to help you work on simplifying algebraic expressions today. So your teacher puts this expression on the board and starts combining things. Dun dun dun. And before you know it, there's a totally different expression on the board. And the teacher expects you to be able to do it too. So let's look a little closer at what really happened. The teacher looked for the terms in the expression that were like. For example, 3x and 2x both have a variable of x. 4y and negative 2y both have a variable of y. And the constants, well, they don't have a variable at all. After determining which ones were alike, we simply add them together. 3x plus 2x is 5x. 4y minus 2y is 2y. And then the constants negative 2 plus positive 3 make a positive 1. So we end up with a simplified version of the original expression. But this is kind of a shortcut. So let's think about why this shortcut works. So if we take 3x and look at it closely, 3x really means 3 times x. And sometimes variables can be confusing, so let's take it back to grade school and say 3 times 2. And what we learned in grade school is that 3 times 2 is the same as 2 plus 2 plus 2. And we know that 3 times 2 is 6. And 2 plus 2 plus 2 is also 6. So we can use that same rationale for 3 times x and say that 3x is the same as x plus x plus x, right? Let's take that sort of thinking and put it to work in an expression. Take our constants, negative 2 and 3, add them together to get 1, and let's put that out of the way for now. Then we're going to take our, we're going to take our 3x and we know that is the same as x plus x plus x. And we're going to keep going with that same thinking as we get to our 4y and say that that must be y plus y plus y plus y. And we have 2 more x's. So we'll say that that is the same as x plus x. And then we have a minus 2y. And we'll say that that must mean minus y plus y. So when we look at it this way, it's pretty easy to see that we have 1, 2, 3, 4, 5 x's. But when it comes to the y's, we have this little subtraction sign to deal with. Do you remember the distributive property? So in essence, this really means that we're adding 2 negative y's to what we already have. So if we add 2 negative y's to the 4 y's that we have, that's essentially taking 2 y's away from the 4 that we have, giving us a total of 2y. And then we take that constant of 1 and put it back in, And we have the same expression our teacher got. But you can see how the shortcut is a lot faster. So that's why we use a shortcut. So let's work another one out together. And I'm going to use some different variables in here. It's okay. You can pretty much use any letter for a variable. Don't let it freak you out. Here we've got some R's and some X's. And now that we've got an expression here, we want to find our like terms. So I see that I have 5x's here and 2x's there. That's like terms. I also have some r's, 7 and -3r. And then I do have a constant, but it doesn't have anybody to buddy up with, so it's just kind of on its own. If I do the shortcut technique, then I'm literally just taking the terms that are similar and plugging them together. So I got 5x plus 2x, 5 and 2 makes 7x, and then 7r minus 3r, 7 minus 3 gives us 4r, and then we keep our constant of -3 to get a simplified expression of 7x plus 4r minus 3. And you can see the shortcut is just a lot faster. If we were writing out all those x's and r's, it would have taken us a long time. So now I'm going to write an expression down here at the bottom for you to work out on your own, just to practice on your own. I got 8p minus 2 plus 6s plus 5 minus 4p and minus 2s. So again, I want you to work this one out on your own. The answer's next, so pause if you're not ready. All right, we're going to take our like terms. We got 8p and minus 4p. And then we have a 6s and a minus 2s. And then we have some constants, minus 2 and positive 5. 8p minus 4p will give us 4p. And then 6s minus 2s will give us plus 4s. And then -2 and a positive 5 give us a positive 3 for a simplified expression of 4p plus 4s plus 3. Great stuff, guys. If you didn't get this very well, just let me know. Shoot me an email, and I'll help you out another way.